It's a rather simple problem in that it gives you a lot of information already. To start with, it asks, is this reaction spontaneous or thermodynamically favored at 25 Celsius? And that's where the information is run from. And so when we take a look, all we need to look at is delta G. It tells me that delta G is positive. So if delta G is positive, what do we know? We know that it is not favored. Okay, it is not thermodynamically favorable, so it's not spontaneous. So then B is asking, well, will that change? Will that change if I heat it up? Well, the thing you have to realize, and this is a very important thing to look at, is that delta G is always spontaneous, always favored when delta H is negative and delta S is positive. If we look at the Big Daddy equation, it just works out that no matter what, if those signs are that way, then delta G will be negative. In the same deal, if delta G is always positive when the opposite happens. Because bottom line, delta G negative means that it's exothermic, it's going to go downhill, and that's favored. Delta S is positive, means I'm getting more messy, more disorder, that's favored. And so two favored things are going to make a favored reaction. The opposite are both unfavored. So if delta H is positive, it's endothermic. It means I have to add money, I have to add energy to it. It's not going to go unless I have enough messiness. Well, a negative delta S means that I'm not very messy, I'm increasing order. And so there's not enough energy to do both of those things, and so this is automatically not favorable, so not spontaneous. Where the problem comes in is when they're the same value. When they're both negative or when they're both positive. So the deal here is delta G depends. And it actually depends on temperature. And so when delta H is negative, it doesn't need a lot of temperature. It's exothermic. And so this usually happens at very low temp. It will become a negative delta G. Okay, so negative delta G. And just the opposite here, at high temp, it would become a negative delta G. And so if we test that theory out, 1200 K is a pretty high temp. And so it's basically saying, hey, just plug this into granddaddy equation here. And so if I have delta G equals delta H minus T delta S, and now I know that it's telling me that to not change the delta H and the delta S significantly, so just kind of plug it in. And so I know that this is 178.1 kilojoules per mole minus my 1200. And then my delta S, which is a positive, but remember, joules, kilojoules, ding, 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 we've got to move the decimal over. Don't ever forget that with S. And so 0.1605 kilojoules per K mole. So it's kilojoules per K mole. So again, our K's cancel. So when you work that problem out, you end up with a negative 14.5 kilojoules per mole for your delta G. So what do we see? We see a negative, which means it's favorable. It's got leftover free energy, so it can be spontaneous, or what we now call thermodynamically favorable. So next question says, now we have this, and this is a very interesting thing in that during a phase change, a boiling point, a melting point, delta G is considered at equilibrium or zero. Well, that makes it very nice because look what we can do with this formula. Delta G is equal to delta H minus T delta S. Well, if delta G is 0, that allows us to solve for temperature. As long as I know delta H and delta S, I can find T because I'm going to move. So let's just kind of mathematically, if I add T delta S to both sides, I'm going to get a T delta S equals delta H. So then delta H over delta S equals T. That's so nice. So then let's just plug in. But what do we need to remember? We need to remember that whenever we have, I gotta get my little thing to go up here, and it doesn't want to move on me. There we go. What we want to do is we want to plug in our numbers, but again, always look at that unit. For delta H and delta S, they have to match joules and kilojoules. So I'm going to move my delta S over, like I always do, to 0.09384. So I'm just going to plug in. Delta H is 33.1 kilojoules per mole. Delta S, 0.93, so 84 kilojoules per k-mole. So what's so nice about this is look who all cancels out. And I leave one little symbol there, my unit is Kelvin. And so when you just do that quick division, you end up with that T is equal to 352.7 Kelvin. And that means then that what they were looking for is what is the boiling point. And so I know that that is my boiling point of this particular substance. That equals to the boiling point.